Hi everyone, how are you going? My name is Miss Sue, and today we are learning how to name simple ionic compounds. Let's get started. Basically today what we're doing is we are converting the name of an ionic compound to its related formula. In this situation, the name of an ionic compound is lithium oxide. So how are we writing the formula for lithium oxide? So previously in our previous lesson, we learned about how ionic compounds are formed, and yes, they are formed generally from metallic and non-metallic elements. So metal elements are always written first and non-metallic elements are written next. Yeah. And as we learned previously, metal elements are the ones that's giving out electrons, and because they are giving out electrons, they become positively charged. And the non-metallic elements will be the ones that is receiving electrons, and because they are receiving electrons, they become negatively charged, and that is how ionic compounds are formed. There are a few tips and tricks to make this writing this quicker. Let's just keep going. This is our periodic table, and I have actually rewritten this in a simplified form. I've looked through our worksheets, and these are most of the elements that we're using. So I've written this down. As we know from the periodic table, this side that's on the left side over here consists of metal elements, and on the left side over here, these are all the non-metallic elements. If we look at the first column over here, yeah, this column consists of lithium, sodium, and potassium. I put a +1 here, and let me explain this. Yeah. So for lithium, sodium, and potassium, they have electron configurations as stated over here. As we can see, there is actually a sort of like a common similarity over here. This means that these three elements actually have one valence electron on their outermost shell. We learn about electron configuration, and the first level starts with 2 electrons, and therefore we need to have 2 electrons on its first level, and then we will move on to the next based on the atomic number over here. And so because these three elements actually have one valence electrons each, so in order to achieve stability, they will be giving out 1 electron each, if that makes sense. And therefore, by giving away 1 electron, they will have a +1 charge. Yeah. So if we look at the second column over here, and as you can guess it, because I put a +2 here, yeah, these elements will have 2 valence electrons on their outermost shell, and they will be giving out 2 electrons, and therefore they have a +2 charge, and that means that all the elements on the second column will have a +2 charge. Yep. Let's ignore the transition metals at this moment, because we're doing this in our next lesson. And look at aluminium. So I have actually included aluminium only because in order to shorten this, and also because aluminium is very commonly used in our formulas. So aluminium has an electron configuration of 2, 8, and 3, and therefore it has 3 valence electrons, and therefore it needs to give out 3 electrons, and that's why it has a +3 charge. Yeah. I hope it makes sense. And if you want to further understand this, feel free to pause this video and investigate with other elements on the periodic table. Yep. And if you have any questions here, feel free to post any questions at the comments below. Okay, so now let's look at the non-metallic elements. So these are non-metallic elements, and as we learned just now, the metal elements are the ones that's giving electrons, and yes, now non-metallic elements are the ones that's receiving electrons. Yep. And so when they receive electrons, they will become negatively charged. So if we look at this column over here, this column consists of nitrogen and phosphorus. And nitrogen and phosphorus, because they are of their atomic number, they have the electron configurations as stated here. So we know that nitrogen and phosphorus have something in common, and that is they have 5 valence electrons at their outermost shell. They cannot give electron, and therefore they have to receive electron in order to be stable. So how many electrons should they be receiving? You are right, they should be receiving 3 electrons. Yeah. So by receiving 3 electrons, this means that they have a charge of -3. So if we look at oxygen and sulfur over here, oxygen and sulfur has 6 valence electrons on their outermost shell each, and therefore they need to receive 2 extra electrons each, and that's why they have a -2 charge. So of course, if we look at fluorine and chlorine, they will need to receive an additional electron, and that's why they have a -1 charge because of their electron configuration below. Yeah, so once we sort of understand this at the back of our heads, let's try to do some exercise. So this is what was stated just now, lithium oxide. So that's the name of the ionic compound. And I know the answer is given here, but what are the steps that we have to take to go from here to here? So the first thing that we have to do is we have to know that what is lithium, and there are some rules behind it to make sure we are following the similar rules in order to write the formula. So lithium is actually this one over here. It has the atomic number of 3. Yep. So lithium is it's a metal. Yep. It's written this way. It has a +1 charge, and we have to know that when it has a +1 charge, we do not write the 1 there, we just write plus. That means it has a +1 charge. Yeah. It is a cation, so it's a positive ion, and metals must be written first, and in this case the lithium must be written first in the name. Yeah. So oxide comes from the word oxygen, and as we know, oxygen has an atomic number of 8 over here. So oxygen is a non-metal. Yep. So it can be written as O2 negative. 2 negative means that it has a -2 charge, and because it has a negative charge, it is an anion, which is a negative ion. Yep. So it has to be written mixed, and because it is also a monatomic anion, it means that it has only 1 atom. So we have to substitute the suffix of the name oxygen with I. Yep. So it becomes oxygen becomes oxide. Yep. So lithium and oxygen will combine together to form lithium oxide. So now that we know this, let's continue on to sort of figure out how many electrons are needed. Yep. So in order for ionic compounds to be formed, yep, we know that lithium has a +1 charge, so lithium can only give out 1 electron. However, in this case, oxygen needs 2 electrons. So how are we going to solve this problem? Yes, you are right. We need 2 lithiums, because 2 lithiums will then give 2 electrons, which the 1 oxygen needs. And that's why we need 2 lithium ions and 1 oxygen ion. So because of this, we need to write the formula as Li2O. Yep. So I took this part from our notes. So this is actually a shortcut. So we know that lithium has a +1 charge, and oxygen has a -2 charge. So we will use the 2 here as and cross over here to write it as the lithium, because we need 2 lithiums. Yeah. And 1 oxygen, so the 1 goes into here, if that makes sense. Yep. So feel free to pause this to further understand it, or else let's go on and do another one. Yep. So our next exercise is, how do we write calcium chloride's formula? Yep. In order to do this, the first thing that we have to do is we have to identify where in our periodic table is our calcium. And yes, you are right. It is right here. So because calcium is at the second column over here, calcium has a 2 plus charge. Yeah. So chloride comes from the word chlorine. And as we can see over here, chlorine has a negative charge, so it has a -1 charge. Yeah. So therefore, in order for the ionic compound to be formed, we need 1 calcium ion and 2 chlorine ions. Why is that so? That's because calcium will give out 2 electrons, but 1 chlorine actually can receive only 1. And that's why we need another chlorine to sort of receive the 2 electrons. So 1 calcium ion and 2 chlorine ions are needed. So we write the formula as CaCl2, and that's because we could actually because chlorine has a -1 charge, we use 1 as the number over here, and calcium has 2. It's written over here. And oh, I forgot to say that when we write formulas, we do not write the charges in. As you can see previously as well, we do not write the charges in. So that's one common mistake that students make, is that they write the charges into the formula. We do not do that. Yeah. So yeah, so this is how we write the formula for calcium chloride. And this is the end of our lesson. Please continue on with your homework. And if you have any questions, yeah, post at the comments below, or you can contact me during class then. See you then. Bye bye.